Determine the slope of the line that represents each linear relationship. Remember, this can be found by y2 minus y1 divided by x2 minus x1. So 4 minus 3 is 1. 6 minus 3 is 3. So the slope here is 1/3. You will need to complete 1 through 4 for your warm-up. In this clip, you will see the battery life of 2 phones throughout the day. Today we're going to focus on how functions change, specifically for functions that change at a constant rate. What do you notice between these two different phones? Well, in the morning, phone 1 was at 100%, but phone 2 was only at 88%. Throughout the day, phone 1 dropped significantly to 28%, but phone 2 stayed pretty similar to what it started as, at 81%. Based on the information in the tables, compare how the owners of the phones might be using them over the course of the day. It looks like the owner of phone 1 uses it a lot and more later in the day, whereas the user or the owner of phone 2 seems like they don't use their phone much at all. B. Describe how the battery charge for each phone changes over the time period shown. Well, phone 1 decreases from 100% to 28% in 14 hours. That is a change of 72%, and that is a drop, so it went down 72%. However, phone 2 drops from 88% to 81%, also in 14 hours, which is a change of a drop of 7% battery life. C. Do either of the tables represent a linear relationship between the amount of time passed and the amount of battery charge remaining? Explain. To determine if it's linear, it needs to have the same rate or slope at all intervals of time. Let's go back and look at the table. If we subtract here 88 minus 100, that would be a change of going down 12, and 4 minus 0 would be 4. So if we were to find the rate between these 2 points, that would be negative 12 divided by 4 is negative 3. If we look between these two, 86 minus 88 is a change of going down 2, but 6 minus 4 is 2. Negative 2 divided by 2 is negative 1. Since these are not the same, then they do not have the same rate. That is not a constant rate for phone 1. Here, this dropped 2, but went up 4. That is a slope of negative 1/2. From here, it dropped 1 and dropped 2, or increased 2 here. That is also a slope of negative 1/2. Here it dropped 3 and went up by 6. Negative 3 over 6 also reduces to negative 1/2. So phone 2 does use a constant rate. So we're going to say yes, phone 2 is linear because the rate is the same at each interval of time. Meaning between any point in time, the rate when we divide is going to come out to -1/2. D, if you indicated a linear relationship in part C, find the slope of the line that passes through the points represented in the table and write an equation representing the relationship. Well, in the form y equals mx plus b, m represents the slope or the rate, which we said was -1/2. The b is where it starts on the y-axis. If we look back at this table, on the y-axis, it started out or has an initial value of 88%. So our b value would be plus 88. You can see in this slide that they've calculated the rate for each time interval from the values in the table. In phone 2, they all came out to -1/2. However, in phone 1, they're not all the same, so this one is not linear. Remember, to calculate the slope, we use y2 minus y1 divided by x2 minus x1. For problems 2 through 8, complete the table by determining whether the function is a linear function. If it is linear, determine the rate of change and describe what it means in the context. 2. A cable TV provider charges a one-time installation fee of $100 and then $75 per month of service. Let Y represent the total amount or the amount charged for cable TV in dollars for X months of service. This is a linear function because it's written in the format y equals mx plus b. Since it is linear, what is the rate of change? It is 75. And what does it represent? It represents the cost per month of service. Three, we have a table for time in weeks and amount of money saved in dollars. To determine if it's linear, we want to know if it is a constant rate. 85 minus 55 is 30. 5 minus 2 is 3. And 30 divided by 3 comes out to 10. 105 minus 85 is 20. 7 minus 5 is 2. And 20 divided by 2 is also 10. Since these are the same, it is a linear function because it has a constant rate. What is the rate? The rate is 10. And what does it mean in the context? That is $10 saved per week. Four. For school, Nora needs to read for 15 hours over the summer. She decides to read 1.5 hours each week. Let Y represent the number of hours Nora still needs to read for school. Let x represent the number of weeks since the start of summer. Is this function a linear function? Yes, it is. This is slope-intercept form, but they've rewritten it as b plus mx. They've used the commutative property to rearrange the order. What is the rate of change? The m goes with the x. The rate of change is negative 1.5. And what does it mean in the context? This means that each week she reduces or decreases the number of hours that she still needs to read or has left to read by 1.5 hours. So each week she reduces the amount of hours she still has left by 1.5. Is this a linear function? Yes. It is linear because it makes a straight line. And it says, well, what is the rate of change? Well, each time it's going down 2 and over 1. So that is a rate of change of negative 2, down 2 over 1. And it means the amount on the gift card goes down $2 per day. Or you can think of it as they spend $2 per day from the gift card. Six, is this function linear? 27 minus 20 is 7, 2 minus 0 is 2, and 7 divided by 2 is 3.5. 34 minus 27 is 7, and 5 minus 2 is 3. But 7 divided by 3 is not 3.5. So this is not linear. The rates are not the same. 7 divided by 3 comes out to 2.3 repeating. Since these don't match, the rate is not constant. This part is only to be done if it is linear. Since it's not, we don't have to fill in that box. Seven, a band is paid $350 for each ticket sold to their concert, plus a one-time performance fee of $2,000. Is this function linear? Yes. How do we know? There is a constant rate between tickets and amount paid. If it is linear, what is the rate? The rate is 3.5, and it means that the band earns or is paid $3.50 for each ticket sold. Eight. I have the number of months reading the books on Henry's reading list and the number of books Henry has not read on his reading list. If we subtract here, 24 minus 30, it went down 6. 2 minus 0 is 2. Negative 6 divided by 2 is negative 3. 21 minus 24 is negative 3. 3 minus 2 is 1. Negative 3 divided by 1 is negative 3. 12 minus 21 is negative 9. 6 minus 3 is 3. Negative 9 divided by 3 is negative 3. So is this linear? Yes, it has a constant rate. Constant rate or a constant slope. If it is linear, what is that rate? That rate is negative 3, and it means that the books he has left to read goes down by 3 each month. That means in 1 month, Henry reads 3 books, so the amount he has left to read is going down by 3. Generate a linear function. Complete the table to show the outputs of your function assigned to select inputs. You can pick different values for your inputs. And then we're going to figure out outputs based on some rule that we come up with in our brain. It needs to be linear, so it must have a constant rate. I'm going to use 2x minus 5. You can come up with your own linear function. 2.3 times 2 is 4.6. And then if I subtract 5, that leaves me with negative 0.4. 9.4 times 2 minus 5 is 13.8. 7.6 times 2 minus 5 gives us 10.2. 0.1 times 2 minus 5 is negative 4.8. You are creating your own list, but you can trade with a partner and see if they can guess what the rate was between your input and output. That is the end of lesson 6. For module 6, you can check the playlist for more lessons from module 6.